Imagine, if you will, a world where our built environment, the very fabric of our cities and homes, isn't just a collection of temporary structures, things that are just destined for the wrecking ball and then, well, a landfill. Instead, try picturing every single building as this vast, intricately organized vault, a material bank, you could call
A
it,
material bank.
where every window, every beam, every brick is meticulously cataloged, its value is understood, and its purpose is ready, really, to be renewed for the next generation of construction.
Hmm.
Okay, let's maybe unpack this a little. Today, we're diving deep into a concept that genuinely promises to fundamentally transform how we design, how we build, and even how we unbuild our world.
That's a key part, the unbuilding.
Absolutely. We're talking about the circular economy specifically as it applies to construction.
Right.
And we've got this really fascinating stack of sources to explore everything from the nitty-gritty of advanced building information modeling, BIM practices, to some surprising insights from the history of material science, and even, philosophical underpinnings of systems thinking.
It really connects a lot of different threads.
It does. It's a journey that asks us to fundamentally rethink the very DNA of our built environment, peeling back layers of assumptions about, well, permanence and disposability.
Yeah, and what's truly compelling about this deep dive is, I think, how it pushes us beyond just the simple idea of recycling. That's often where the conversation stops, doesn't it?
It does, just sorting the waste at the end.
Exactly. But we're talking about a holistic reimagining of the entire life cycle. How we design, how we construct, operate, and then, crucially, how we disassemble structures.
Mm.
So our mission today, really, is to extract the most important nuggets of knowledge from all these diverse sources we have, to sort of illuminate how we can shift from that ingrained linear take, make, waste model,
The one we know so well.
the one we know too well, and move towards a truly resourceful, regenerative one, where buildings are conceived right from day one as these dynamic material banks for the future. And as you'll discover as we talk, this isn't just some, environmental aspiration or a nice to have.
Right.
It's really becoming an economic imperative. It's a pathway to greater resilience, innovation, and ultimately long-term value creation,
Right.
especially in a world where resources are getting, well, increasingly constrained.
That's a really important point. To truly appreciate this vision, though, this circular economy vision, we first need to properly confront the reality of how we do things now.
Yeah, the baseline.
Let's start with the status quo, because
Right.
it's so deeply ingrained in our industries and our mindset, isn't it? The linear model of construction.
It is.
We begin by extracting just vast quantities of raw materials, often with really significant environmental impacts. Think of the energy-intensive mining, the logging, the processing required just to get the basic stuff.
Mm-hmm.
Then we take these materials, craft them into components, build with them, use them just once in a structure, and then at the end of that building's operational life, which frankly can be far too short sometimes, maybe just a few decades.
Sometimes surprisingly short.
Way too often, it all just ends up in a landfill, piled up.
Yeah.
It's such a short-sighted, disposable mindset. It's a cycle that's been repeating for centuries, really. I mean, from ancient Roman construction, maybe, to modern practices with drywall and adhesive strips, though obviously the materials and the scale of waste are vastly different now.
Yeah, and if we connect this to the bigger picture, this deeply embedded take, make, waste approach,
Yeah.
it might seem straightforward on the surface, simple.
Get raw materials, build, throw away.
Right. But it actually carries these immense hidden costs and systemic inefficiencies that just ripple through the entire supply chain and way beyond. Our sources, particularly the ones focusing on lean construction principles and product lifecycle management, PLM systems, they really highlight the substantial waste inherent in these traditional linear methods. They draw some really compelling parallels to the inefficiencies found in manufacturing before, lean principles completely transform that sector.
Right. Like with Toyota and just in time.
Exactly that kind of thing. So, for instance, the BIM handbook explicitly details how traditional construction suffers from inventory holding costs. That's the financial burden of just storing materials you don't need right away.
Yeah, stuff sitting around on site.
Right. And multiple handling, which increases labor costs and the risk of damaging things every time you move them.
Mm-hmm.
Then there's damaged or lost parts on site, which happens all the time, and complex shipping coordination issues,
Mm-hmm.
especially for what they call engineer to order or ETO components.
Those are the custom-made things.
Exactly. The highly customized, unique elements made just for one specific project. Managing those is a headache, And these aren't just, abstract environmental burdens we're talking about. These are direct quantifiable hits to a project's budget.
Yeah, real money.
Real money,
Yeah.
affecting everything from the critical path schedules to the overall profitability. So this really raises an important question. If these inefficiencies are so pervasive, what exactly are we taking and wasting that we could be doing better?
Right.
And how can we mitigate these losses effectively, not just at the landfill at the very end, but across the entire life cycle of a building? It really challenges our whole notion of efficiency, doesn't it?
It absolutely does. That's a pretty stark picture of the current reality, the linear way. So, okay, what does this all mean for how we build, how we think about our built environment going forward? The circular economy offers this powerful and really comprehensive alternative to that take, make, waste mentality.
Wow.
It's not just a tweak, or with some small incremental improvement, it feels like a complete paradigm shift.
Yeah.
And it seems to be built on three foundational core principles.
That's right. 3 key ideas.
Yeah, it's about consciously designing out waste from the very beginning, keeping materials in productive use for as long as humanly possible, and then actively regenerating natural systems instead of just depleting them.
Regenerating, not just sustaining.
Exactly. It's a truly transformative vision, and it seems like it requires a really holistic approach, looking at the whole picture.
Yeah, and what's truly fascinating here, I think, is that these 3 principles demand this fundamental reorientation in our thinking. They really push us to move beyond isolated project-based decisions.
Like just focusing on this one building right now.
Precisely. Where you might optimize for a single phase, maybe the construction cost or a specific component, without really considering its downstream impact, what happens later. Instead, we need a holistic view that encompasses the entire life cycle. Our systems thinking sources actually remind us that to live successfully in a world of complex, interconnected systems, well, we need more than just cold calculation. It demands our full humanity, as one source puts it, encompassing rationality, yes, but also intuition, compassion, vision, and even morality.
Interesting. How does that apply to construction?
Well, in this context, it means understanding the really intricate feedback loops that exist between, say, design choices made early on
Right.
and material sourcing, construction methods, how the building is used over decades, and then its eventual deconstruction. It's about recognizing that a decision made at the drawing board, maybe choosing a certain type of adhesive, can significantly impact how easily a valuable material can be recovered, maybe 50 years later.
Wow. Okay, so thinking way ahead.
Exactly. This kind of thinking lets us build true resilience into our processes and our structures. It fosters a built environment that can adapt and endure. We're moving away from just solving the problems we see right now to proactively designing a more sustainable and, importantly, regenerative future right from the ground up.
Okay, let's zoom in on that first principle then, designing out waste. Because this isn't just about reducing what goes into the SIP at the end of the job or even just recycling some leftover bits.
No, it's much earlier than that.
It sounds like a much more proactive, almost preventative approach. It challenges us to stop waste from being created in the first place, right, throughout the entire process.
Absolutely.
From the initial conceptual design through meticulous procurement, efficient construction, and even into how a building operates over its lifespan.
Yeah.
It demands that we fundamentally rethink how we approach every single step, asking, okay, how can we engineer waste out right from the start?
Indeed. And our BIM handbook and lean construction sources, they provide really concrete evidence of how powerful these proactive strategies can be. For example, adopting just-in-time production practices, which, as you mentioned, were pioneered in manufacturing,
Right.
can substantially reduce inventories of those engineer-to-order ETO components we talked about, those custom elements unique to each project.
So you don't have loads of expensive custom stuff sitting around?
Exactly. And this isn't just about preventing physical trash piling up. It's about eliminating the costs of storage for idle materials, reducing the labor and the risk involved in multiple handling,
Yeah.
minimizing those damaged or lost parts on a, let's face it, often chaotic construction site,
Definitely.
and streamlining that complex shipping coordination. Imagine a scenario, right? A custom fabricated facade panel arrives precisely when it's needed for installation. It goes directly from the truck to its final spot on the building.
Okay.
There's no need for it to sit in some muddy laydown area for weeks, getting potentially damaged or even stolen.
Yeah, I can picture that.
So by rigorously streamlining the supply chain, ensuring materials and components are delivered exactly when and where they're needed, this proactive elimination of waste dramatically enhances overall efficiency. It reduces costs. And it's a critical, often overlooked aspect of genuine circularity.
Hmm.
It's really about getting things right the first time, every time, and making sure that value flows through the entire process without unnecessary friction or loss.
And that leads us perfectly into the second principle, which feels like the real heart of this material bank idea, keeping materials in productive use.
Hmm.
Instead of that linear, one and done approach we're so used to where a material serves its purpose and then it's just discarded, how do we make sure that valuable resources and components keep circulating within the economy, keep retaining their highest possible value for as long as possible?
This is precisely where the concept of buildings as material banks truly comes alive.
Yeah.
It fundamentally shifts our perspective from thinking about buildings as temporary structures to seeing them as long-term resource repositories.
Hmm.
Our sources on the historical durability of materials, like traditional masonry or especially charcoal iron, provide incredibly compelling evidence.
Charcoal iron. Tell me more about that.
Well, one source notes that charcoal iron, which was used in many iconic structures from the past, does not readily rust. And even when it corrodes, it forms a black coating of magnetic oxide, which protects it indefinitely.
Indefinitely.
Indefinitely. This isn't just some historical curiosity. It reveals something profound. We've long had the knowledge and the capability to create materials that can endure for centuries, practically forever if maintained.
But we don't always build like that now.
Exactly.
Yeah.
Much of modern construction, often driven by short-term cost efficiencies or maybe just fast-changing aesthetic trends, has inadvertently designed in a kind of planned obsolescence. It makes these potential long-lasting treasures difficult or impossible to recover and reuse. So the real challenge often isn't the material's potential lifespan. It's our economic and design models that have maybe unintentionally chosen destruction over lasting value.
Right.
So this principle, keeping materials in use, actively encourages innovative business models around material recovery. It draws insights from lean supplier development concepts. Instead of just focusing on the lowest price for new materials, the idea is to develop supplier capabilities and foster joint innovation to create robust systems for taking back, refurbishing, and recirculating existing components.
So working much more closely with suppliers.
Yes, building long-term relationships and shared value, moving beyond just transactional exchanges to truly integrate materials back into the economic loop again and again.
Okay, so if designing out waste and keeping materials in use are about sort of minimizing the negative impact and maximizing resource efficiency within our current systems, this third principle, regenerating natural systems, sounds like it takes us a big step further.
It really does.
This goes beyond just doing less harm or aiming for a net zero impact, right? It's about actively improving and restoring our environment through our construction practices. It's about designing buildings that actually give back, leaving ecosystems and human environments healthier than we found them. Is that achievable?
Well, if we connect this to the bigger picture, regenerating natural systems means that buildings can genuinely become active, positive contributors to environmental health and ecological balance. And our sustainable construction sources provide concrete, really compelling examples of how this is already being done, showing measurable, significant impacts.
Okay, like what?
Consider one case study highlighted in the sources: a hyper-efficient HVAC system. Now, in this building, the energy required for moving air through the building was reduced 90%.
90%. How?
Through really ingenious design elements, things like maximizing natural ventilation, using a large exhaust chimney to create a powerful chimney effect that naturally draws air upwards,
Okay.
and even incorporating an earth-coupled canal that uses the stable temperature of the ground for seasonal heating and cooling assistance.
Wow.
Now, these aren't just energy-saving features in isolation.
Right.
They drastically reduce the demand on conventional grid power, which, as we know, often relies heavily on fossil fuels.
Yeah.
So they contribute to a cleaner, healthier energy ecosystem overall.
Right.
And think about cool roofs. Roofs with high albedo, meaning high reflectivity.
Even sunlight back.
Exactly. They're designed to reflect solar radiation rather than absorbing it as heat. Now, by deploying cool roofs across a whole city, our sources show they can significantly mitigate the urban heat island effect.
That's where cities get much hotter than surrounding areas.
Right. And this leads to citywide energy bill reductions estimated at an astounding $26.1 million per year in one study, and saving 468 million watts of peak power annually during peak demand times.
Huge numbers.
Huge numbers. And beyond the energy savings, they also improve air quality. They were shown to decrease ozone of 10 parts per billion because lower ambient temperatures reduce the chemical reactions that form ground-level ozone.
So direct health benefits too.
Absolutely. These aren't passive measures. They are active, large-scale contributions to healthier ecosystems in human environments. They reduce pollution and energy strain on a systemic level. Even something as seemingly simple as maximizing daylighting in buildings, beyond its proven human benefits like productivity and well-being, it dramatically reduces the need for artificial lighting, lowering energy consumption, and the heat generated by lights.
So it all connects.
It all connects. It's about making buildings part of the solution, not just reducing the scale of the problem they create.
That's a truly inspiring set of principles, designing out waste, keeping materials circulating, regenerating systems. But okay, how do we actually do this? How do we put these principles into practice on a real construction site, in a real design office?
Right, the practicalities.
Because here's where it gets really interesting, I think. It challenges decades, maybe even centuries, of conventional building wisdom. If a building is truly going to function as a material bank, like we said, then it needs an efficient withdrawal mechanism, right?
Yeah, you need to be able to get the assets out easily.
Exactly. So this idea of designing for deconstruction seems to turn conventional construction methods completely on their head. It demands we think about the end right from the very beginning.
It does.
It's about planning not just how to construct something, but how to unbuild it later with precision and purpose.
And this raises an absolutely critical question for everyone involved, engineers, architects, builders. How do we actually design buildings so their valuable components can be easily taken apart and recovered for reuse rather than just being smashed into rubble and hauled off to a landfill?
Which is the standard practice now, mostly.
Sadly, yes. Our sources reveal that many traditional construction methods actively create assemblies that are incredibly difficult, if not impossible, to separate cleanly without just destroying the components themselves.
Like what kind of methods?
Well, for instance, one of the builder's guides we looked at points out common practices like using adhesive membrane strips for roofing connections or having drywall caulked, glued, or gasketed to the top plate of a wall.
Okay, things stuck together permanently.
Exactly. Now, these methods definitely provide structural integrity and weatherproofing in the short term. That's why they're used. But they create these permanent, irreversible bonds. Once something is glued or caulked like that, those components are often just destined for the trash heap. Their intrinsic material value is completely lost.
So what's the alternative for deconstruction?
The critical shift is towards methods like assembling components primarily with mechanical fasteners. Think bolts, screws, clamps, maybe even cleverly designed interlocking systems, rather than using irreversible adhesives or welding everywhere.
Things you can undo.
Things you can undo. This allows components to be recovered with their value largely intact, ready for future use. And interestingly, the concept of prefabricated components, things like standardized roof trusses, stairways, pre-hung doors, which are mentioned in the shop class as Soulcraft's source.
Right, things built in a factory.
Exactly. That already highlights the inherent benefits of modularity. Now, while that specific source wasn't explicitly talking about deconstruction, the very nature of prefabrication often creates standardized separable units,
Ah, I see.
which inherently enables easier disassembly and reuse down the line. It's a fundamental change in the end-of-life scenario, moving away from destructive demolition and massive waste generation towards precise disassembly and valuable material recovery.
Okay, so we've thought carefully about how to unbuild our structures using fasteners and maybe modular parts. But even the most accessible vault isn't much good if you don't know what's inside, right?
Good point. Inventory is key.
Which brings us to another crucial piece of the puzzle. Knowing precisely what valuable materials are actually stored in these building banks we're creating.
Yeah.
And that sounds like where technology really has to step in with things like material passports and sophisticated digital tracking to truly understand and manage our assets.
And what's really fascinating here is that we don't necessarily have to invent this wheel completely from scratch. We can draw direct parallels with other mature industries that have been managing complex product life cycles for a long time.
Like aerospace or manufacturing.
Exactly. Our BIM handbook describes product lifecycle management, or PLM, systems used in sectors like electronics, manufacturing, aerospace. These systems effectively manage the entire life of a product, from initial design and engineering through manufacturing, service, and eventual disposal. They involve sophisticated product model management, inventory management, material and resource tracking, and scheduling. That whole package.
Okay.
And that is precisely the blueprint for what material passports aim to achieve in the construction sector.
So BIM is the key here, building information modeling.
BIM tools provide the absolutely foundational capabilities. They allow us to extract counts of components, area and volume of spaces, and material quantities from the digital model of the building. However, for these digital models to function as truly effective material passports, they need to be really robustly supported by clear object classification, consistent naming conventions, and a standardized attribute structure.
Meaning everyone agrees on how to label and describe things.
Precisely. Imagine knowing the exact type, quantity, manufacturer, maybe even the original source or recycled content of every single material in a building,
Wow.
along with its key properties: fire rating, structural capacity, potential for reuse, maybe even its embodied carbon, all linked directly to its digital twin in the BIM model.
That's a lot of data.
It is, but it's incredibly valuable data. And this isn't some completely futuristic dream. It actually builds on historical knowledge. Think about how different building stones or types of iron were specifically chosen and known for their durability and provenance centuries ago.
Right, like the charcoal iron example.
Yeah, exactly. But now we're scaling that knowledge and digitizing it. This transforms every building into a transparent, verifiable, and traceable material bank.
And you mentioned these aren't just static records, right? Like a dusty file somewhere. We're talking about dynamic inventories.
Absolutely. They need to be living documents. Our City of Tomorrow source paints a picture of the immense potential of integrating sensors, networks, and data-driven feedback loops to create truly smart spaces.
Sensors in buildings.
Yes, potentially an entire ecosystem of sensors that continuously collects real-time information about the urban environment and the buildings within it. Now, when you integrate this sensor data with advanced BIM models, geographic information systems, GIS for spatial context, and interactive web portals like the U.S. Coast Guard roadmap example for facility management showed, you create this powerful, living digital infrastructure. This allows for the continuous tracking and management of building components throughout their entire life cycle. You can update their condition, their performance, maybe even their reuse potential in real time based on sensor data or maintenance logs.
So the city itself becomes a kind of database.
In a way, yes, it becomes a reflexive testbed, as the source calls it, a workshop for connected living, where data about materials, their in situ performance, and their potential for reuse is constantly being collected, analyzed, and updated. And furthermore, this transparency can be amplified through open data platforms. Imagine making this information accessible, appropriately anonymized, of course, not just to city planners and developers, but also to citizens, researchers, innovators.
That could spark new ideas.
Exactly, enabling things like cross-neighborhood comparisons of material stocks and flows, as outlined in the City of Tomorrow source. This moves beyond just theoretical models to provide real-time, actionable insights, fundamentally transforming how we manage our urban fabric and its valuable material assets.
Okay, this is really starting to come together. We've designed our buildings for deconstruction. We know exactly what materials we have thanks to these dynamic digital passports and smart tech. But once those materials are carefully recovered, they can't just sit in a warehouse indefinitely, can they?
No, absolutely not. That just creates another form of waste, really.
Right. So we need a viable, robust market for them. How do we actually cultivate an economy that values and actively wants to reuse salvaged materials?
This strategy involves, I think, a fundamental paradigm shift away from the common perception of salvaged materials as somehow being secondhand or inferior.
The used stuff stigma.
Exactly. We need to move towards recognizing the inherent value, the quality, and often the superior durability of these materials. Historically, materials like York stone, various types of limestone, and that incredibly resilient charcoal iron we keep mentioning, they weren't just seen as building blocks, they were prized assets. Often salvaged meticulously from older structures and proudly reincorporated into new ones precisely because of their proven longevity and unique aesthetic appeal. People valued that history and robustness. So a circular economy in construction would actively promote, grow, and probably standardize a market for high-quality salvaged materials. And the selling point isn't just their environmental benefit, although that's huge. It's also their proven performance, their unique character, and often, as I said, their superior durability compared to some newly manufactured alternatives.
Okay.
For instance, the Fundamentals of Building Construction source even mentions relatively modern examples, like new types of concrete formwork panels that are especially smooth, durable, and easy to clean, specifically designed to be reused dozens of times.
Yeah, the idea of reuse is already there in some areas.
It is. And this concept of designing for robust, durable, reusable components applies broadly across the entire built environment, from massive structural elements right down to interior finishes. By actively fostering demand for these recovered materials and components, maybe through policy incentives, maybe through better information platforms, we create powerful economic incentives for deconstruction over demolition.
Makes sense.
It effectively closes the loop and provides builders with a rich, new, and often potentially cost-effective source of high-quality inputs. And at the same time, it reduces the demand for virgin resources and all the energy and environmental impact associated with their extraction and processing.
Okay, but even with the best design for deconstruction and great markets for salvaged materials, there will inevitably be some things that can't be directly reused as components, right? Or materials that reach the very end of their useful life in their current form.
That's true, yes. Direct reuse isn't always feasible or the best option.
So what about the waste that inevitably arises then? This brings us to waste utilization and something called byproduct valorization, basically, turning what was once considered garbage into a new resource.
Yeah, and here's where it gets really interesting, I think, in terms of pure resourcefulness and chemical or material ingenuity.
Okay.
The circular economy really challenges us to see waste not as an end-of-life problem to be managed, but as a potential input for a completely new process, a raw material just waiting for its next transformation.
Finding value in the discard pile.
Exactly. Our Fundamentals of Residential Construction source provides a perfect, very practical example of this with something called Controlled Low-Strength Material, CLSM concrete.
CLSM concrete. What's special about that?
Well, it's not your typical high-strength structural concrete. It's purposely formulated to have a very low, but importantly, a known and predictable strength. And its primary use is as a backfill material for filling trenches or voids.
Okay, like a flowable fill.
Precisely. But what's often overlooked, or the key circular aspect, is that CLSM can often incorporate things like recycled aggregates from demolition waste, fly ash, which is a major byproduct from coal combustion power plants, or other industrial waste that might otherwise be landfilled.
So it's using waste materials in the mix.
Exactly. So it's not just about pouring some weak concrete into a hole. It's about taking materials that might otherwise be considered a disposal liability, like leftover concrete from a batch plant, crushed demolition debris, or that fly ash, and reformulating them to serve a specific valuable engineering purpose as a controlled backfill. It perfectly embodies the designing out waste principle by transforming what would be a liability, something costly to dispose of, into a useful product.
Right.
It significantly reduces the need for digging up virgin aggregates like sand and gravel for backfill. It minimizes landfill impact, and it can prevent environmental pollution from waste stockpiles. It just highlights the vast potential for innovative thinking around material composition and application, turning liabilities into assets.
That's a great example. Okay, and finally, strategy number 5. We've talked about design, tracking, markets, waste utilization. How do we make the entire process from the very first design concepts right through to material recovery and reentry into the economy? How do we make it all smoother, more predictable, and just fundamentally more efficient?
Yeah, optimizing the whole flow.
How do we reduce waste from the very get-go, proactively, rather than just reacting to problems? This seems to bring us to the powerful combination of lean construction principles and really deep supply chain integration.
Absolutely. Lean construction principles are incredibly synergistic with the circular economy. They foster a culture of continuous improvement, relentless waste reduction in all its forms, time, materials, effort, and maximizing value creation across the entire project lifecycle.
And BIM helps with lean, right?
Hugely. The BIM Handbook notes an impressive 55 positive interactions between BIM and lean construction, really showcasing how complementary they are. For example, BIM's ability to create those detailed 3D models with rich data helps teams identify potential clashes between building systems or optimize designs for constructability before anyone even breaks ground.
Finding problems on the screen, not on the site.
Exactly. Which directly reduces rework, a massive source of wasted time, money, and materials on traditional projects. And concurrently, lean practices like just-in-time delivery, which are often enabled by BIM's sophisticated scheduling and logistics capabilities, reduce that wasteful inventory we talked about and minimize unnecessary handling.
Okay.
Now, our Practitioner's Guide to Lean Research source emphasizes the critical importance of supplier development. This shifts the focus beyond just haggling for the lowest price from a supplier for basic commodity.
Right, not just about cost.
No, instead, it prioritizes capability development and joint innovation. That means working collaboratively with suppliers to enhance their ability to deliver high-quality, perhaps prefabricated components precisely when needed, maybe even designing components together for easier assembly or disassembly.
A real partnership.
A real partnership. This truly helps ensure that materials and components are right the first time, significantly reducing errors, material defects, and ultimately waste on site. The guide highlights improving delivery precision and quality as key outcomes, which directly translates to less material ending up in the skip and more efficient projects overall. Furthermore, frameworks like the theory of constraints, made famous by the book The Goal, offer a powerful methodology. It's about identifying the bottlenecks in any system and solving problems before they arise.
Proactive problem solving.
Exactly. It's an approach often used in designing new manufacturing plants, but it's directly applicable to anticipating and preventing waste right from the earliest stages of building design and construction planning. By fostering these robust, collaborative supply chains and integrating lean thinking throughout the entire project lifecycle, from cradle back to cradle, we can achieve substantial improvements. The source gives that compelling example where focusing on supplier reliability resulted in delivery reliability went up in 6 months from 80% to 95% with a relatively small effort. That demonstrates tangible financial benefits running alongside the clear environmental ones.
For many people listening, the phrase circular economy might still sound like, well, an admirable environmental ideal, maybe a noble goal for some distant future, perhaps a bit niche.
Yeah, green thing.
A green thing, exactly. But what we've been uncovering today, looking through these sources, makes it really clear it's much, much more than that. This isn't just about being green, it's fundamentally about being economically smart. It's about building truly resilient businesses and supply chains and actually creating entirely new value streams that can bolster our economies.
Absolutely. If we connect this back to the bigger picture, adopting a circular approach in construction creates incredibly compelling economic advantages. It's a shift from that cost-burdened, often inefficient, linear model to a potentially value-generating circular one.
How so?
Well, firstly, it actively fosters completely new business models. Think about businesses built around material recovery and processing, high-quality remanufacturing of components, or even innovative concepts like leasing building components instead of selling them outright.
Leasing, like leasing the facade or the lighting system.
Exactly. Imagine a specialized lighting company maintaining ownership of all its light fixtures within a large office building. They provide light as a service, handling maintenance, upgrades, and then, crucially, taking back those fixtures for refurbishment, remanufacturing, or recycling at the end of their service life in that specific building.
Interesting. Creates ongoing revenue.
Creates ongoing revenue streams and builds longer-term customer relationships. And critically, on a macro level, a circular economy provides powerful insulation against volatile material prices.
Because you're using less new stuff.
Precisely. By reducing reliance on virgin raw materials, which are constantly subject to global market fluctuations, supply chain disruptions, geopolitical instability, businesses gain much greater control and predictability over their input costs. By increasing the use of internal recovered resource loops, they build resilience.
That makes a lot of sense, especially now.
It does. And the concepts from The Goal, that foundational text in operations management about optimizing the whole system, not just achieving little local optimums within individual departments or project phases, are highly relevant here. By relentlessly reducing inventory, which ties up capital, eliminating waste through proactive problem solving right back in the design phase, and streamlining all the processes involved, companies can achieve really substantial cost savings and significantly improve their overall throughput.
Throughput meaning?
Meaning getting more valuable output like finished, usable building space generated with fewer resources and less time invested. It's about efficiency in the truest sense. And our lean construction sources just reinforce this repeatedly. They show that focusing on improving basic capabilities and tracking simple metrics like percent promises kept by suppliers can lead to rapid improvement with fairly small effort.
Like that delivery reliability example.
Exactly. That jump from 80% to 95% delivery reliability in just 6 months. That directly translates to fewer project delays, potentially lower contract penalties, better cash flow, and an improved reputation in the market, all things that directly boost profitability. The economic case is becoming undeniable.
Okay, the economic case is strong, very compelling. And while those benefits are clearly significant and far-reaching, the environmental case for circularity in construction is, of course, absolutely foundational. That's often where the conversation starts.
It usually is, yeah.
But let's maybe highlight some specifics again from our sources that really show how this goes beyond just basic sustainability or doing less bad towards active regeneration and even measurable improvements in human health and well-being.
Right. Because the environmental benefits detailed in our sustainable construction sources are sometimes truly radical. They demonstrate reductions in environmental impact that genuinely move beyond simply mitigating harm to actively restoring natural systems, sometimes on a surprisingly grand scale.
Okay, hit me with some examples again.
Well, let's go back to that hyper-efficient HVAC system we discussed. The one that achieved a staggering 90% reduction in the energy needed just for moving air through the building, thanks to natural ventilation, the chimney effect, the earth-coupled canal.
Right.
Now imagine scaling designs like that across thousands of buildings. You could drastically cut carbon emissions from building operations globally, a huge contributor to climate change.
Yeah, that's significant.
And on a larger urban scale, remember those initiatives like cool roofs with high albedo? The sources showed a potential citywide energy bill reduction of $26.1 million per year.
Still staggering.
It is. And saving 468 million watts of peak power annually during peak demand times. That reduces the strain on electrical grids, prevents the need for building polluting peaker power plants. And crucially, beyond the energy savings, these cool roofs were also shown to improve air quality by decreasing ozone of 10 parts per billion. That's a direct positive health impact on the people living and working in that city.
Less smog, cleaner air.
Exactly. These aren't just minor tweaks. They represent systemic regeneration of energy systems and air quality, literally making cities healthier places to live. And furthermore, the sources highlight the often underestimated power of simply maximizing daylighting in buildings. We know it feels nicer, but the impact is bigger.
More natural light.
Yes. It not only significantly reduces energy consumption for artificial lighting, but studies have shown it can have profound positive impacts on human performance and well-being. The sources cited increases in retail sales by 30–50%,
Wow.
raised student learning rates by classrooms, and potentially increased office worker productivity by 10–15%.
Those are huge numbers, potentially far outweighing the energy savings cost.
Absolutely. These productivity and revenue gains alone often yield savings that far exceed energy costs, demonstrating powerfully that environmental benefits can, and often do, go hand in hand with substantial human and economic advantages. So, while the energy savings are important, the broader human and environmental benefits truly mark a transition. It's moving from mere sustainability, trying to minimize harm, to a genuinely regenerative approach, where our buildings actively contribute to healthier environments and more productive, thriving lives for the people using them. #outro.
Well, today we've embarked on what feels like a truly transformative exploration. We've looked at how buildings can potentially shed this identity as temporary structures, inevitably destined for waste,
Yeah.
and instead become these dynamic, incredibly valuable material bags for the future. We've seen how those core principles, designing out waste right from the start, tirelessly keeping materials in productive use, and actively regenerating natural systems aren't just aspirational ideals. They look like practical, achievable goals.
With the right approach, yes.
And critically, we see how these principles are supported, even enabled by cutting-edge technologies. Things like BIM for detailed inventory management, digital material passports for tracking components, and smart city networks for dynamic resource allocation across urban areas. This whole approach, it isn't just environmentally sustainable, it seems profoundly economically intelligent too. Creating new business models, fostering resilience against shocks, generating real long-term value. It really feels like a fundamental shift in how we even conceive of our built environment, doesn't it? Moving from that disposable mindset to one of enduring value and stewardship.
It really does. And this raises an important question, I think, for all of us. For every architect, every engineer, every builder, policymaker, and frankly, every inhabitant of our urban spaces.
Yeah, it affects everyone.
It's a call for a fundamental rethinking of the entire building life cycle. From the very first sketch in the design phase, through meticulous construction and thoughtful operational use, and ultimately to that planned, careful deconstruction and the seamless re-entry of materials back into the broader economy. Our systems thinking sources remind us that changing the system's underlying goals is one of the highest level interventions possible. It's one of the most powerful leverage points we have for real transformation.
Changing the goal itself.
Changing the goal itself. We're talking about moving from a short-sighted, disposable mindset to one characterized by long-term stewardship and profound resourcefulness, where we collectively define and pursue a new, regenerative goal for our built environment. A goal where the intrinsic value of the materials we use should endure for as long as human ingenuity allows them to.
So, as you look at the buildings around you, maybe it's your home, your office, or those towering structures that define your city's skyline, consider this final provocative thought to take away. What if every single window, every steel beam, every brick, maybe every sheet of drywall, every single component came with its own digital passport? Not just detailing its origins and composition, but actively anticipating and waiting for its next life, its next purpose, rather than just its final, wasteful resting place in a landfill. What new architectural forms might emerge from designing for disassembly and reuse? What innovative new industries centered on material recovery, remanufacturing, maybe component leasing could flourish? And what truly regenerative urban landscapes might we create when we fully embrace buildings not as disposable products, but as infinitely valuable, potentially renewable resources, just waiting for their next chapter in our evolving world?